Okay, so now we're going to deal with sines and cosines combined together where there's combinations, meaning even and odds, or just to odd powers. Remember, type 1 was just even powers. So like this one, cosine cubed, or this one, sine to the fourth, cosine cubes. This is what I would call a combination of even and odd powers. And here's with just odd powers. Very different technique. So what we're going to do is we're going to work U substitution backwards. You are very familiar with U substitution, so we're actually working it backwards. So that means you're starting with the du. So you're going to start with either du as sine of x, or you're going to start with du as cosine of x, not with the u. When you're choosing which to make your du, you're going to leave even powers and you're going to use this identity. Sine squared plus cosine squared is 1. You know that identity, I know. You are never to use half angle formula when doing this method. Okay, so when doing this method of working the U substitution backwards, you're never to use half angle formula. You will get stuck. Okay, so it's going to make sure you're using this identity instead. So let me show you how it works. So here's cosine cubed. So I'm going to look at this cubed. I want to leave even powers, so I'm going to make it cosine squared times cosine. So I'm going to use the phrase, I'm going to peel this cosine off and put it beside the dx because this is what I'm going to make my du. So that would be my next step. I'll say du equal cosine of x dx. So because I'm thinking about u substitution, what must the u be so that my du is cosine? My u must be sine. Right? So I just worked it backwards. So now I'm going to make this u substitution work just like I usually use u substitution. So to use u equals sine of x into here, well, this will be taken care of with du, but I need to rewrite this with sines in it. So that's where I use this identity. Cosine squared plus sine squared is 1. It gives me cosine squared equals 1 minus sine squared. So I'm going to replace cosine squared with 1 minus sine squared, right? Replace cosine squared with 1 minus sine squared. Carry along this cosine of x dx. So notice I've got all x's, and then I'm going to replace with my u substitution. So I'm going to replace sine of x being squared with u squared. So that's what u is equal to. Du is cosine of x dx. So I take out cosine of x dx. I put in du. Now I'm ready to take the antiderivative. Okay, so let's be careful here. I've got the integral of 1 with respect to u. That's what this du means. So this says that the antiderivative of 1 is u, not x. Be really careful. This is going to happen a lot. Taking the antiderivative of u squared with respect to u gives me 1/3 u cubed. Then I put what the u is equal to. So u is sine x. I put it back in, and I put the sine x back in. Oops, and I forgot my plus c here, didn't I? Okay. Let's move on to another one. So we have to choose which trig function, whether I'm going to peel off a sine or a cosine for my good du. I always want to leave even powers. So since sine is already to an even power, I'm going to leave it. And I'm going to take this cosine cubed and write it as cosine squared times cosine. And I'm going to write the cosine with the 1 power beside the dx because that's going to be my good du. So here it is again, du is cosine of x dx. So I'm going to let u equal sine of x because I'm working u substitution backwards, right? Starting with the du, there's the u. Okay, so now let's make this u substitution work. So if I do a u substitution, this will be taken care of, right? That'll be u to the fourth. This will be taken care of. That'll be du. So I just need to rewrite cosine squared. So again, never the half angle. Never the half angle. I see too many people fall into a pit and pull out the half angle. You'll get stuck. It doesn't work. You've got to use this identity. Cosine squared is 1 minus sine squared. So take cosine squared out. and put in 1 minus sine squared. And so here I've got all x's, my sine to the fourth, my 1 minus sine squared in for cosine squared, my cosine of x. Now I'm ready to make my u substitution work. So this gives me u to the fourth, 1 minus u squared, cosine of x dx is du. Now we're going to multiply this out before I take the antiderivative. So u to the fourth here, and then u to the fourth times u squared. You know, let me just write it here, u to the fourth times u squared. When you're multiplying, you add exponents, right? So just make sure you're careful with that. And so now I'm ready to take the antiderivative. So this gives me 1/5 u to the fifth, 1/7 u to the seventh, and I put the x's back in, right? Put the sine of x back in. So this has to be written out so you know what your what your u is equal to and what your du is. All right, let's move on to sine cubed. So I've got an odd power only, so let's peel off one of the signs. So I leave an even power, and this is a good du. So du is sine of x. So then my u is, I've got the negative. And I'm actually going to give it a name and call it the negative issue. All right, this is ugly. You have never let u equal negative cosine when there's no negative in the problem. So I'm going to suggest you rework it, and I'm making this suggestion because I want to help you make the least amount of mistakes. So if you go forward with this, almost always I see people making mistakes. So what I'm going to suggest is when you see that you've got du is sine of x dx, and you get to this, you stop and you say, okay, I'm going to let u equal cosine, du is negative sine, and then I'm going to put the negative out here by the du that's equal to sine of x dx. That's what you're used to, letting u equal a positive when there's no negative in the problem, correct? Okay, so let's see what we've got going on here. So with this, sine of x dx will be taken care of with negative du. Sine squared of x, I need to get in terms of cosine. So I'm using my identity. I know that this sine squared is 1 minus cosine squared. Now I've got all x's. I'm ready to go to all u's. So I put u of cosine in here, so 1 minus u squared. Sine x dx gets replaced with a negative du. And then I'm going to take the time to pull this negative and put it out in the front. And then I'm ready to take the antiderivative. Antiderivative of 1 is u, because we're taking the antiderivative with respect to u. Antiderivative of u squared is u cubed over 3. And then just put the x's back here, the cosine of x back in for the u, and we're done. Okay, so I want to make sure that you're careful of when I'm doing this negative issue. So we just came from doing integration by parts, and we had negatives and we left the negatives. So let's remind you. So if I had a problem like this, I did u equal x and dv is sine of 2x, and if I got a negative here, I left it. You didn't move it around. You left the negative where it landed, and then you just carried along and you put it in where it went. It's only when I'm doing this backwards u substitution that I'm suggesting that you move it, and it's only when you get a sine of x dx. So I just wanted to make the comparison.